Here's another example on rationalizing the denominator. I have this expression here. Rationalizing the denominator means get rid of the square root term in the denominator. And to do this, I need to find the conjugate of the denominator. So if I have, let's talk about conjugates again really quickly. If I have 5 plus the square root of 10, the conjugate is going to be 5 minus the square root of 10. What we do is we switch the sign, and that's our conjugate. Okay? So what do we do with the conjugate? I use the conjugate to get rid of this. What I do is I multiply by 1, but the 1 is disguised as a conjugate. Okay? I will write 5 minus the square root of 10 and 5 minus the square root of 10. These have to be identical so that they're equal to 1. And I want to multiply by 1 because I don't want to change the original value of this expression. So by multiplying by 1, I keep the original value. It's just going to be dressed up differently. Now when I multiply fractions, I multiply numerator times numerator and denominator times denominator. Notice in this example, I have a product of binomials in the numerator and a product of binomials in the denominator. And this is what that looks like. It's going to be 1 plus the square root of 3 times 5 minus the square root of 10. All of that over 5 plus the square root of 10 times 5 minus the square root of 10. Okay? Now to multiply the numerator, I need to use FOIL, and I also need to use FOIL in the denominator. But I'm not going to use FOIL in the denominator because anytime you see that you have a number and its conjugate being multiplied together, this becomes a difference of squares. And here's what I mean. Whenever you have a plus b times a minus b, your answer is going to be a squared minus b squared. That means take the first number and square it, and then write minus, and take the second number and square it, and you get your answer. That fast. If you want to go ahead and do the FOIL, you could. You're going to get to the same thing, okay? I'm going to do it the long way here, just to convince you that it's the same. Okay, so we have our numerator here. This is not a difference of squares because they are not conjugates of each other. So I have to use FOIL here. I'm going to do this operation over here on the side so I don't make a mess. So I have 1 plus the square root of 3 times 5 minus the square root of 10. I take the first number times the first one here, 1 times 5, that gives you 5. And I take that same number times the second term, which is negative square root of 10. So 1 times negative square root of 10 will give you negative square root of 10. I'm done with this first number. Now I take the second term and I multiply by the first term. Square root of 3 times 5, that's 5 square roots of 3. And then square root of 3 times negative square root of 10, that's negative square root of 30. Okay? And that's what you get for your numerator here. Now, let's try and simplify this a little bit. 5, I don't have anything else to combine it with. Square root of 10, I can't combine with anyone else because for this to have a like term, I would need another expression with the square root of 10. Square root of 30, let's see, I can break 30 up into different factors. I can say 1 times 30, 2 times 15, 3 times 10, 4 times nothing, 5 times 6, and then 6 times 5, and you're done. Those are the factors for 30, and none of those factors are perfect squares. Therefore, I cannot simplify square root of 30. Okay, so this expression remains as it is. I cannot combine any of the terms. So for my numerator, I have 5 minus the square root of 10 plus 5 square root of 3 minus the square root of 30. In the denominator, if I go ahead and take the denominator now, for the denominator, I'm going to come here off to the side, and I'm going to use FOIL, even though I know that it's going to equal this shortcut, just to show you. 5 plus the square root of 10 times 5 minus the square root of 10. I take the first term times the first term, that's 25. I take the first one times the second term, that's negative 5 square roots of 10. I take this one times the first one here, and that gives you plus 5 square roots of 10. And then this one times the second term, which is minus square root of 100. Let's simplify this. Since this term here and this term here are like terms. How do I know they're like terms? Because the radicands are equal. I treat them like x's. These two terms cancel out. I have 5 square roots of 10 minus 5 square roots of 10. That's 0 square roots of 10. Okay? So I'm left with 25 minus the square root of 100. And that equals 25 minus 10, which is 15. Because the square root of 100 is 10. That gives you 15. Whoops, 15. Let me make this better. 15. Okay? This is using FOIL. If I would have used the shortcut that I taught you here, then if I show you the shortcut, let's see what we get. I get 5 plus the square root of 10 times 5 minus the square root of 10. And I said that would be this number squared, which is 25. Well, let me write the whole thing out. That would be this first number squared, which is 5 squared, minus this number squared, which is square root of 10 squared. And that would equal 5 squared is 25 minus the square root of 10 squared, which is the square root of 10 times the square root of 10. This is the square root of 10 times the square root of 10. That's what the square root of 10 squared is, right? So this is 25 minus the square root of 100, which is 25 minus 10, which is 15. And we get the same thing, using FOIL or using the shortcut. Okay, so my denominator here is 15. And notice that I was able to rationalize the denominator. I don't have any radicals in the denominator. Okay, I hope you understood, and I'll see you in the next video.